Daniel, thank you for joining us. Us at Enginears, we're back again. We've got the absolute pleasure of talking to Daniel Gebler, who's at Picnic, and he's the CTO of Picnic. He's going to tell you guys a little bit about what he's doing, what the team are building, and we've actually got a pretty awesome subject around robotized warehousing. So I'm going to let Daniel kick us off and talk to us a little bit about that. So Daniel, say hello and tell us a little bit about what we're going to talk about today in Picnic.
Thanks, Elliot. Great for having me. My name is Daniel. I'm CTO of Picnic, and we have a very simple mission. We want to make grocery shopping, especially online grocery shopping, simple, fun, and affordable for everyone.
Cool.
Our mission started a couple of years back when we actually observed that all of us are pretty comfortable to buy non-food items online. So everybody buys books, electronics, fashion already online. So if you look to those kind of retail categories, then already 30, 40, 50% and more is online. While food is a pretty much an underserved category. In food, only 1, 2, 3% has been online. And we started to look in this market and try to see why is nobody buying food while everybody buys non-food items online. We identified a couple of reasons, and that was the starting point of Picnic. So I myself came to Amsterdam to do my PhD here.
Okay.
I like the city, like the people, stayed, and that was the starting point of Picnic.
Good for you. All right. So give us a little bit more of an understanding of maybe the backdrop and what's happened over the last couple of years. We obviously understand there's some funding there, and we're going to talk a little bit about what that funding's used for, but it'd be really good to understand just a little bit more context about what's the journey been? What's the journey been over the last few years?
So when we saw that food is an underserved category, we asked the question, why is nobody offering a convincing proposition to deliver food online? And the reason that we identified is that customers just don't want to pay for the deliveries, and customers don't want to wait.
Okay.
And that is something which, from consumer research, is not too hard to find out.
Yeah.
But the real reason or the real kind of challenge that the market had is that nobody came up with a solution or had a convincing solution to fulfill this customer needs in a kind of a viable business option.
Okay.
So we looked into different kind of logistical models, different fulfillment models that would allow us to deliver at lowest price without delivery fees at always on time to customers. And that was the starting point of Picnic, early 2015. And when we identified how this could look like, we said, well, let's find out if this proposition would be interesting also for customers. So we built an MVP, and in stealth mode, we launched the proposition. So stealth mode means very simple. We had an unbranded proposition. We simply said to customers, this is something what we want to do. This is what we offer. Would you like to buy it? And then we served only 2, 3, 5, 10 customers per day.
Okay.
So now just think about the sizes. Now we are delivering to tens of thousands of customers. But at this point in time, we had only a few customers that we wanted to serve, and we iterated every single day over the proposition, but also the technology behind the scenes to come up with a model that both serves customers in the best possible way, but on the other hand, can also be scaled from 1 to 10 to 100 to 1,000 and then tens of thousands of customers.
Okay, we can, or it'd be really actually interesting to explore some of that scale and how the trajectory's moved, obviously over the years. But talk to us a little bit about the fulfillment process. That's obviously massively important for you guys. That's the core business. And talk to us a little bit about how you use technology to leverage the best capabilities from that.
Fulfillment and warehousing is something that the industry, the food industry, but also non-food, has been doing already since tens or dozens of years. And in a fulfillment environment, what happens is you have basically two streams of products. Okay. You have a stream which is called an inbound stream, which means that all the kind of the trade units of products are coming in. These means 24, 36, 48 packs of milk, of Coke, but also other products. And then you have the kind of the outbound stream where you put together all the orders of customers, where you have then a banana, where you have cheese, where you have cucumbers, where you have milk, where you have butter, all the products are coming together, what the other customer has ordered, and that will go out in a packaging which goes directly to a single type of customer. So these are kind of two types of streams where you have a lot of kind of steps in between. You have a replenishment step, you have a picking step, you have a dispatching step, and all those single steps are steps that are done traditionally in a manual
Yeah.
way. And one of the key innovations that has happened in this world over the last kind of 20 or 30 years is something which is not even about robotization, which we will talk
Yeah.
later about, but it's something even much more modest. In the past, all those processes have been done by a paper pick operation. And paper pick means something super simple. If you are working in a warehouse and you have a couple of hundred people that are working
Yeah.
share, you got in the morning a sheet of paper, and then you were going all the day through the warehouse, and you picked all the products that you had on the sheet of paper. You started on
Yeah.
top, you went to the bottom, and on the bottom usually your day was done, and then you went home. And this operation, as a first step or first innovation step, we brought to an app-based or an application-based, web-based,
Yeah.
mobile-based picking operation where operators see in an app what are the kind of the tasks, and then you can have real-time dashboards, and you can see in real
Yeah.
time who is doing what, where do you have a shortage of people, where you have maybe more capacity and can reallocate your picking capacity.
Nice. Okay. We actually spoke about, not necessarily you and I, but I've spoken about optimization a couple of times, and real-time dashboards, monitoring, or all of these other fancy things now that you can use to look at what's happening with your platforms. How do you look at, I guess, making yourselves more optimal with some of the data that you've got in front of you?
So the first step, what if you move from a paper-based operation to an app-based or software-based solution, is that you get real-time insights, what is happening in your warehouse. And giving feedback to warehouse operators or warehouse pickers is that you build dashboards. And dashboards means you can build on different levels. So you have a dashboard for the entire warehouse where you see how far did you come with your daily operation, and then you can at one point put the actual graph, and you can you put in the same graph also a kind of a target line, and then you see are you already on the target, or do you need to speed up, or maybe you have even are above the target. This is one thing, but even more powerful is if you drill down to specific areas of your warehouse operation. Food usually operates in a multiple temperature zones.
Okay.
Think about you have ambient products, which are normally fruit and
Yeah.
vegetables and other products, and like bread and butter, and, bread, for instance. But then you have also chilled products, so products that are more kind of 5 to 10 degrees. And then you have frozen products. This is, for instance, all your frozen pizzas and similar
Yeah.
products. So in this kind of different temperature zones, you want to know how are you progressing on picking frozen pizzas versus picking chilled products like fish or sushi,
Yeah.
etc. And on the other hand, how fast are you progressing in the ambient ones? So the first iteration that you do in such an environment is that you give real-time feedback over dashboards to your order pickers and everybody else in the warehouse. And the next step that is happening is after giving feedback, you can think about how do you make this feedback cycle a little bit more fun.
Okay.
You don't want to give feedback numbers where you say now you're that far and you can either speed up or slow down, but you want to actually also reward everybody in the warehouse with getting badges. And we took an analogy from all the fitness apps.
Gotcha.
The fitness apps themselves are probably the most have are the apps that put most thinking in how do you motivate to do
Okay.
tasks that actually are per se not the most rewarding ones. Because exercising, if you do it regularly, then you love it, and hopefully all of us do it regularly. But if you start from a non-exercising state to start with exercising, then you need to first build up a habit.
Fine.
And the same kind of gamification we also build in our warehousing environment, where you can actually earn badges, where you go through kind of different stages through the
Interesting.
cycle and unify the entire warehousing operation.
Okay. We're obviously going to be really keen to understand a little bit more about the architecture and the design of this, because there'll be physical infrastructure as well as AI, machine learning, and other things that I'm sure go on. But it'd be really useful to understand a little bit more about the technology stack and what
Yeah.
technologies you leverage.
So in this world, and this is a pretty interesting because warehouse automation itself is something that has been already done in various stages and various maturity levels over many years. So the first warehouse automation happened actually in the 60s based on a patent from the 1950s implemented by General Motors. The interesting things here is that this is obviously very simple from today's
Yeah,
perspective. Automation
thank
has
you.
happened. In our, in our world, what we have deployed is we moved directly to warehouse applications, web-based and mobile-based applications. So these are kind of Android-based applications that are deployed on the rugged Android devices that all our order pickers and the warehouse personnel
Yeah,
have. And they see basically on a real time which kind of tasks they should do and where do they need to go physically. So the tech stack is on the front end side, Android applications, and the Android applications themselves are applications using Ionic and a web-based kind of web-based application deployed in a container. And on the back-end side, we are using Java-based services that are deployed in Amazon. So we don't have physical service in the warehouses, but it's a completely cloud-based and deployed over Docker and Kubernetes, and then infrastructure as service over Terraform.
nice.
So this is a bit roughly our stack that we're using here. We started with document databases, so with MongoDB, which was pretty efficient to store a couple of
Okay,
tasks. At some point, we realized that there is much more relation in this kind of documents that we initially envisioned. So then we moved from a document-based database model to a relational database
okay,
model, and there we moved over to Postgres, where we store all our relations. And relations are in this world, for instance, that a task is linked to the product that you need to pick, linked to a kind of a location, linked also to an outbound target, an outbound goal, maybe to a truck where you need to actually dispatch it in, etc., etc.
okay. Um,
So this is roughly kind of the tech stack that we have there. And in Amazon itself, that is deployed over just a couple of servers. So even if you're operating such an application for a few thousand people, you don't need too many servers in the end and in a public cloud
Good.
environment.
Okay. Like I said previously, before the technology stack question, building a warehouse like this, okay, robotized warehouse, like I said, the physical infrastructure or installation all the way through to some of the robotics, the AI, and all the technologies that sits in between that. How have you designed that? How have you built that?
The first thing what you do is if you have a hunch or a feeling that robotic automation could be reasonable for you, is that you don't think about robotics. So what do
Okay.
I mean by this? If you think about a warehouse or fulfillment operation,
Yeah.
you're thinking about the movement and the flow of goods through your warehouse during the kind of inbound operation and then a different kind of location in the warehouse towards an outbound operation. So the first step that we did is we looked into the flow of goods that we have now and are those flow of goods linked to people movements. And the interesting thing is that people movements take time, cost money, and this is something which, if you do automation, that all those kind of time and money components are moving away because moving robots in the warehouse is the marginal cost is close to zero. So therefore, you have a complete different flow of goods if you optimize or if you robotize or if you
Yeah.
automate the move of goods by robots. So the starting point was for us is if you take all the kind of the time and the movement costs away, how would the optimal flow of goods look like in a warehouse? And what we realized there, and this is obviously something which the entire industry
Yeah.
realized, is that instead of as an order picker that you move to a product that you pick like in a
Yeah.
physical warehouse from the first aisle products and from the second and from the third aisle, that this is actually not efficient What you need to do is the products need to come to you as an order picker or as a robot picking arm, and you don't need to go to the products, but the product comes to you. So therefore, you actually reverse the movement of the products in the warehouse in a way that becomes optimal for picking and not optimal for movement of a person through the warehouse. So this is the first starting point. After the design of the new flow of goods, you basically design the robotization or the level of robotization around this. And if you're talking about designing a level of robotization, the realization that we had there is it is not a binary decision between to which extent you automate if you automate something or not automate it, but the real question that you need to ask, to which degree do you automate the process? So therefore, this term of RPA, so robotic process automation, is actually a misnomer. It's about robotic process augmentation.
Okay.
And augmentation means the degree on how, to which extent and the process can be robotized or should be robotized.
Fine.
And what you realize here from this analysis is that both a fully manual process or fully human process is not optimal. In the same way, also a fully automated process is also not optimal. Usually very expensive to realize and very much error prone. And somewhere in between this and this scale, the optimal degree of automation is. So therefore, you look to around between 100 and 150 different kind of sub-processes in a warehouse, and you decide for every process, what is the optimal degree of automation? And if you have defined the degree of automation, then you design the tools behind it. What are the kind of the right robotic tools that you use for this? And that could be, for instance, a kind of movement, actual robots that are moving products from left to right. That can be conveyor belts, but it can be also other tools of automation that are looking that are just simpler and automate or basically replace and augment human operations. So that means could be, for instance, kind of enforcement of human labor with a robotized kind of force arm, something like that.
Okay.
And this is basically the design process that we went through. And then we looked into also what is the underlying technology that we can take there. Robotization is something that existed or has been done already for quite some time. So therefore, technology that exists there looks relatively old. So if you talk to automation providers, then they talk about software stack that you would consider more kind of suitable for a company 10 or 20 years ago, but it's still offered there. So for instance, cloud-based solutions are pretty uncommon in this world. And what we saw there is that there is a reason why you want to deploy some of the technology locally. And the reason for this is the latency between an on-premise robot and the cloud control software needs to be obviously very low, the latency. So that means we made quite an analysis which kind of components, which kind of sensors, which kind of actors allow for which kind of latencies. And we saw that the kind of the low-level controls need to actually be deployed locally because you need the latency which is sub-millisecond, while the high-level control of different components in the warehouse can be deployed in a warehouse in a public cloud environment, because their latencies of something like 20, 30, 14 milliseconds is definitely good enough. So this was a kind of the infrastructure decision. And then in the next step, we design a software system, which is these days obviously a kind of a microservice architecture, which is API first and API based. So that means you design from the interfaces and then the implementation architecture, and then you think about the actual implementation decisions that you need to make. And then we drill down such a project to the point where you have a kind of a pretty big project planner. You know that you need to spend a couple of thousand man days in it, and then you form project teams that can realize the different milestones.
Yeah. Okay. Are you fully operational at the moment with all of this?
Not yet. And this is the fun of it. So we actually raised a little bit of funding last year to start this project. This was last November, where we had raised 250 million to bootstrap this project. We started at the beginning of this year to do the implementation. And this is a project that will run for the entire 2020 and a large part of 2021. And we are planning to go live shortly after. And the interesting thing is this is such a complex system where so many components, physical components, but also digital components, software components, control components, sensor components play together, that you will have a pretty long ramp-up phase.
Okay.
And a ramp-up means that you have beside the normal QA cycles, and this is then called FAT and SAT,
Yeah.
so factory acceptances, site acceptances, and many, many other kind of tests. Also a kind of a ramp-up phase where you say that the entire capacity of the warehouse you have just after somewhere around a year after fully operating the warehouse, you have just run after a year with the full capacity.
Okay. Do you think even moving away from warehousing slightly, and this isn't necessarily what we've discussed before, but even on the street deliveries, could they be robots? I've heard stories of that previously where they've trialed in areas of square miles, I think it is, where they've been able to send out food deliveries. Is that something potentially that could be on the horizon or not?
There are definitely interesting options that you can think of. So there are delivery companies that look in options to use drone technology. There are companies looking into autonomous robots. So there have been examples both in US but also in London,
Yeah.
where for instance, pizza robots are moving around the streets on the sideways. There are examples where you think about to which extent can you use autonomous vehicles to deliver to households. Obviously, the question is, while we are now talking about automating a part of the last
Okay.
mile, what do you do with the last meter or the last foot of delivery? So most of the concepts are now organized like a kind of moving the pickup point close to a customer. While with this kind of autonomous delivery, you still need, as a customer, go out of the house and go to the kind of the robot that is on the sideway or on the street itself. Um, we have not really decided what will be the right thing as a kind of or which kind of avenue we will go there. Internally, we have engineers that are both trained and have done quite a bit of experimentation and tests around all those technologies. So we are ready to
Okay.
move into this space
Nice.
if it matches a bit. But for now, what our customers love, and that is a kind of our service proposition that we have built up since day one, is the kind of the moment at the door where one of our delivery guys, we call them runners, delivers the groceries to the customer with a smile, with a nice apron, with
Good.
a kind of a very nice, let's say,
And a
protocol
social
that's followed.
distance 2 meters as well,
That
please.
is these days, indeed, these days, this is contactless delivery. There's a 1.5 meter
Good.
distance and everything related to keeping everybody safe and
Good.
healthy. But this is something which obviously would be replaced, and we are careful in replacing this immediately with another proposition. But this is definitely, from a technology angle, a very interesting avenue that we are also
Yeah.
considering.
I can imagine this might sound like a bit of a strange question, but what are these robots going to look like? Are they going to look like you and I, humans, or have you designed them specifically like, as robots, or what you see in the films? Because otherwise, we're going to end up with something out of one of these films, like the Skynet or something. It's going to be
Yeah,
crazy.
it's, it's a funny question. So maybe if I zoom out a little bit from picnic and take a broader view,
Yeah.
then we all know, and there is a common understanding in the industry is that one or the other way the robots are coming.
Okay.
But what is happening is that these are not kind of killer robots a la Will Smith and
Please
friends
no.
that have a kind of a cinematic 2035 kind of
Okay.
scenario, which will all kill us if something goes wrong or Skynet like.
Yeah.
But we are talking about robots that will do augment and extend and support tasks that we do as
Okay.
humans. And there are in the entire robotic automation world, there are kind of two avenues that have been taken. On the one end, there is this avenue where you have robots like, for instance, Sophia, that are designed as humanoid robots that look like humans, that also have all the sensors and actors like humans, and that become a more kind of human support and companions for kind of daily tasks. And you see in a couple of areas and societies, those kind of robots fulfill already an important role. For instance, you see in Japan, where those kind of robots replace to some extent elderly kind of they have a function in elderly
Yeah.
care. This is one of the areas. What we do in the way how we design robots, we want robots to support our workers and our warehouse staff, and we don't want to replace them. And that's something which, on the one hand, in the way how we design the robots, in the way how we design the processes that they do, but also the look and feel of those robots, we take this into account. And that's the reason why, by intention, we make them visually not looking like humans, because we don't want that there is a kind of a misinterpretation that we want them that we want to replace humans.
Okay.
It is all about what we know is that we as human alone are not good enough in a kind of a kind of modern environment, a modern fulfillment of environment. In the same way, robots alone will also not be strong enough and good
Yeah.
enough. And we know that both together, both robots and humans, can form a kind of a new way of workforce that will be significantly better than one of both alone.
Okay.
And that's our vision, and that's what we also want to realize
Yeah.
across all our kind of logistical and operational
Good.
processes.
Okay, so that's obviously a specific choice, which I like. That's good. You touched on a point around some of the sensory feel to robots, and that made me start thinking about how they would actually interact with people in that journey. So, do you want to talk to me a little bit about, I guess, how you architect and design some of those sensors or those touch points, so they're actually programmed to understand what it's like to interact with a human? Because that, to me, right now is super interesting.
Yes. So for the sensors, if you want to go the avenue that a robot will augment and extend and strengthen a human sensor or human
Yeah.
actor, then what we do by design is we are not a human has five sensors and the actors, so that means these are arms and feet and a few more of those kind of actors. By design, you're designing a robot or a robotic element in a way so that it doesn't have all human sensors. Let me give you an example. You are designing the kind of the robotic elements that they focus on, for instance, on visual
Yeah.
sensoric or kind of on audio sensoric or on the smelling sensoric, but you don't combine all of it in a one goal together. So, as an example, if you're talking about a support of a good to person, so that means a good to person flow, meaning that from a storage location of a product, there are some robotic elements that move the product from the storage location to an order picker, which is still a kind of a human element. Then for this kind of flow, you need actually only visual
Okay.
components or a visual sensor to know exactly over which route you go and over which kind of elements on which kind of decisions you do along the way. And as an actor, you need to have all the kind of physical actors to move the goods over conveyor belts or over kind of different routes from point A to point B, but you don't need more. And this is the first step that we do in our automation. And what we see and what we also learn during the cycle, because we design both the robotic
Yeah.
elements and the automation elements together with everybody in the warehouse, and we made demonstrations and we asked everybody for feedback, is that everybody likes that we are focusing on those elements that are actually cumbersome or very laborsome and very hard and sometimes even dangerous for humans, that we did automate this, and that we by design leave out all the kind of nice stuff or all the kind of creative elements still
Interesting.
to humans. And this is a kind of a nice combination that both creates acceptance by the warehouse personnel on the one hand, but on the other hand, also kind of leverages the skills from both sides in the most optimal way.
Nice. I love that. Good. Okay. Obviously, you've mentioned to us a little bit about the journey over the next 1 to 2 years when warehouse will be live. What can we expect from you, maybe in terms of a product or a brand over the course of this year, next year? And has the virus affected you guys at all?
Let's start maybe with the second part of the question. Indeed, the virus has affected us in a bit surprising and interesting ways. So, when everybody is at home, when there are a lot of restrictions on how people move around the streets, how they move around the cities, then you see that everything what is e-commerce related is actually getting a massive boom. In
Yeah.
the same way as most of your listeners have probably heard about the kind of the big spikes of Amazon, of Instacart, and many of the other kind of bigger kind of retailers, we have seen the same also on our
Okay.
side. So for us, it meant that in March, when it became very active here in Netherlands, but also in Germany, we saw demand which was not only 10, 20, 30% higher, but it was actually 1,500%, so 15x higher demand for the products that we were offering. So that meant that we need to quickly ramp
Yeah.
up all capacities, both on, let's say, the digital side. So our friends from Amazon saw then a major spike in the way how we reserved servers, but it meant also that we had to very carefully look into our warehouse and fulfillment
Yeah.
capacity. On the other hand, and this is the interesting thing in a business which is very physical, we had to look also carefully into how do we handle our entire partner and
Yeah.
supplier ecosystem, because most of them have been also affected one or the other way. And for them, it goes the other way around. For them, it became more difficult to deliver in time the right quality, the right quantity. So therefore, we saw on the one hand more demand, on the other hand, harder time for our suppliers. So that was kind of the starting point of the virus. Sorry for that.
That's all right.
And then the second and then the kind of the second in the second phase we see now a normalization. But the normalization is a real new
Yeah.
normal where you see customers are actually buying more kind of bigger baskets more often, more frequent, and you have more customers kind of shopping for us with us in a more regular way. So this is a kind of a new situation that we are coping with, and we are pretty happy to serve all those customers that are sticking with us. Looking to the first part of your question,
Yeah.
what is on our agenda? What is on the roadmap? What is coming for our customers and our partners in the coming
Tell us
weeks
what you
and
can.
months? So what we have so far done, we are running a lot of pilots with customers where we try new business proposition, where we experiment with new ideas. One thing what we learned and realized is a very interesting observation. Um, at some point, we looked a bit into our distribution efficiency, and the distribution efficiency means mainly how many trips can you do per hour, how many customers can you serve with a
Yeah.
vehicle. But then we realized this is an interesting question, but actually, if you look to the utilization of the vehicles, we are utilizing our vehicles only 50% because we go full to a customer and we go empty back. That is not good. This is just not how you utilize
Okay.
your resources. Think about if you for your engineering audience, if you have developers which are 8 hours in a day in your office or wherever they are now, but actually do just engineering for 4 hours, and the other 4 hours they do something else. So this is not so cool. So we thought about what can we do in the remaining time where we have this low utilization of our
Okay.
vehicles, and then we saw that there's actually the complete reverse problem of what we are now solving. So the problem that we solve is we make forward logistics. We bring stuff from a producer or from a manufacturer to the end customer. But there is also an industry which is organizing the flow back to manufacturers or retailers from a customer. And the industry itself is a bit more narrow, but it's still relatively big. And the biggest part of this industry is the fashion industry.
Is the what?
Let
Sorry.
me give you an example of the fashion industry, fashion
Okay.
clothes. So you guys in UK and have, for instance, a company called
Yep.
ASOS, and here in Europe we have also Zalando and a few other fashion
Yep.
retailers, which customers love. However, what they do is everybody orders 5 pairs of jeans and sends 4 back. That's what everybody does because everybody needs only one new
Whoops.
one. So, and this is something what is certainly a challenge for basically all parties
Okay.
involved. So it is a challenge for customers because while the delivery of the 5 pairs of jeans is nice for a
Yeah.
customer, the return of the 4 jeans is much more
Okay.
cumbersome. And obviously,
Yep.
retailers don't encourage it too much. But it's still, if you have now, if you want to send it back, then you are able to send it
Yep.
back. Also, for the retailer, it is a pretty expensive endeavor because you need to organize the entire
Yep.
return flow. You need to clean the clothes and all kind of other stuff. And the third one is it is also not super interesting as a business for the logistics parties that are currently serving it. So what we started to do is we organized when we realized is that we see all our customers at least once per week because food is a high
Yep.
frequency business that we organize this return flow. And this is for instance, for fashion retailers. And this is one of the very interesting propositions that we have been working on. We have piloted this. We have done POCs. We have already started to launch it in a couple of cities, and we will do much more of this. So
Well,
this is one of the important areas. The other one is obviously automation. So an automation is on the one hand the robotic
yep.
automation that we were talking earlier about. There's many more kind of automation and streamlining and machine learning that we are applying now for other
Yep.
processes. An example is if you're serving if you're serving millions of customers, then you have so much feedback that the entire customer service processes you need to use machine learning and natural language processing to actually do pre-classification of feedback that you get from
Yep.
customers in order to prioritize which kind of feedback do you immediately reply to and which ones can wait a little bit. And then as a third part is we are working on a lot of kind of forecasting and growth tools to support our very steep growth, week growth. And the interesting learnings here is, and that is something what is a kind of an insight that we got over the last years is while we are growing, we continue to grow with the same rates. The margin for error that a business, both on the tech and but also on the business side, has is an absolute margin for error. Let me give you an
Okay.
example. The margin for error for misplanning of people, so that means too many or too
Yep.
little people planned in, is roughly always the same amount. You can relatively easily capture kind of 30, 40, 50 people if it's misplanned. Think about if you have 5,000 people, 50 people misplanned means you need to somehow cope for
Yep.
1%. If you now grow, so therefore you can have a margin of error of 1%. But if you grow now, if you double, then with 10,000 people that you have to plan, then your margin for error is still just 50 people. With 10,000 people, the 50 people is only 0.5%. So that means your forecasting needs to be twice as good.
Okay.
So what we learned is in the same way, all our forecasting, everything what we do, predicting the future, forecasting the future, needs to grow and needs to become better in the same rate as we grow. And this is a very, very important area that we are now working on and where we work with basically the latest kind of deep learning and machine learning tools.
Good for you. I love that. Listen, a lot of our listeners, if not all of them, are going to be seriously interested in what you guys are doing. I'm going to be following you over the next 18 months. We've got a lot of engineers listening. Do you want to tell some of the engineers listening and other people, of course, a little bit about some of the roles that you're going to look for over the coming months and years so they can get a better idea? They can obviously reach out to you, they can reach out to your careers page. So do you want to just give us a quick insight before we wrap up, just about what you're hiring and what typical technologies? I know we touched on them at the start, but just give us an overview.
So let me start maybe with the easiest answer to this. So we have a website where you can find both our stack and the open
Yeah.
roles, which is join.picnic.app. We are looking for engineers basically for all kind of roles. if you're front end, if you're back end, if you're Java, if you're Python engineer, whatever kind of engineering background you have, if you are highly ambitious, if you want to work in a team that is strives to build the next generation of robotic automation, of wants to build a kind of a new generation of delivery apps and delivery tools and delivery models, then that is definitely something for you. We are Amsterdam based. We are hiring for Amsterdam. If you come from another place, just reach out. We definitely are open for discussing also a remote joining. We have currently a team of around 200 engineers. We are organized in a couple of product teams, customer facing, but also supply chain facing and platform related tools. We are looking at, beside the classical engineering tools, also for security engineers, for people that are looking especially also in privacy topics, test engineer, test automation engineers, on really low level PLC testing up to the point of high level integration end-to-end type of testing. Whatever is your background, have a look. If you like the domain, if you like what you have heard, you will find even more information and more background in the blogs. We love to share with the community. We have built our proposition with a lot of open source, and we are now in the space and are now in the phase where we are giving back. So we love to also actually help the rest of the industry to automate by making as much as possible of the tools that we develop open source. If you want to be part of this movement, just have a look to join.picnic.app. Join us. See you soon.
Good. I just want to say thank you so much for taking the time to talk to us, but so in depth, so insightful, and maybe it's my ignorance, but I'm a little bit mind blown at the moment. So thank you so much, and I hope everyone enjoys it.
Thanks for having me. Thanks everybody out there. Hope to talk to everybody soon.
Good.
Have a wonderful day. Bye-bye.
Bye.
Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Enginears is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Enginears.io. It's no_. We've also got a website which is enginears.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.